The topic is triple integrals in cylindrical coordinates. So let's do this example. Evaluate triple integral e over e x squared dv, where e is the solid that lies within the cylinder x squared plus y squared equal 1. So let's draw. Here's 1. So assume this is a cylinder. Above the xy plane and below the cone z equals square root of x squared plus y squared. So here's the cone, right? Z equal square root of x squared plus y squared. So first thing we need to know, at what z there's the intersection between the cylinder x squared plus y x squared plus y squared equal 1 and the cone z equals square root of x squared plus y squared. So how do we do that? Let me rewrite both of them here. We know z is equal square root of x squared plus y squared, and we know that x squared plus y squared equal 1. So if you want to know which z it will happen, all you do plus x squared plus y squared equal 1, so replace this by 1. So this means z equals square root of 1, which is 1. So we know this happens at z equal 1. We're going to need that. Why do we need it? We're going to need it to find the reflection, the projection on the xy plane. We know the projection will be, now we can tell it's going to be that circle with radius 1. Right? So first, let's do, so the projection will be a circle. Remember, the solid goes from here to here, right? From xy plane to the cone. But still, the projection will be that circle. Let me write it. The disk with radius 1. Right? So this will be D. So triple integral over e x squared dv. So we start with the alpha. Alpha will go from 0 to 2 pi. The radius goes from 0 to 1. The z goes from here to here. In other words, from this is z equals 0 to, this is the cone, z equals square root of x squared plus y squared. So it's going to go from 0 to square root x squared plus y squared. And our function f of x, y, z happens to be x squared. Remember the formula says, look at the formula, it says r dz dr d theta, right? And again, we need to do the inner integral first. So this will be equal integral from 0 to 2 pi, 0 to 1, and square root of x squared plus y squared. X squared plus y squared is equal r squared. Square root of r squared is r. And then x squared will be r cosine theta, everything squared. So that's r squared cosine squared theta. And don't forget this r. Let me write it here. Now dz dr d theta. It's going to be equal 0 to 2 pi, 0 to 1. Now this is r3. Now remember, all of this is a constant, dz, so that will be r3 cosine squared theta times z between 0 and r, which is equal, we're going from 0 to 2 pi. Now all I need to do, plug in the r for z. If we plug the r, it will be r times this r3, so that will be r4 cosine squared theta minus 0, so I don't have to write that one down, dr d theta. I forgot the integral from 0 to 1. Right, now we need to do, this is going to be dr, so cosine squared will be considered constant, so that would be r 5 over 5 cosine squared theta between r is between 0 and 1 d theta. This will be equal integral from 0 to 2 pi, plug in the 1 for r, it's going to give you 1 over 5 cosine squared theta minus 0 times blah blah is 0, so d theta. This is going to be equal 1 over 5 integral from 0 to 2 pi cosine squared theta d theta, and that's just one of those integrals you're supposed to memorize, so it's right there, it's easy to do. So that would be equal 1 over 5 1/2 theta plus 1/2 sine theta between 0 and 2 pi. I can get rid of, take 1/2 outside, so 1 over 5 times 1 over 2 theta plus sine theta between 0 and 2 pi. That's going to be equal 1 over 10, plug in the 2 pi plus sine of 2 pi minus 0 plus sine of 0, which is equal to 1 over 10, 2 pi, this goes to 0, all of this goes to 0, which is pi over 5. And that's it for this example.